And action. Okay, here we go. From our lesson yesterday. Right, order of operations and powers. Let's go over some special ones. Okay. So if we get a power that looks like 6 to the first power, what do you think the answer is? 6? Okay. Whoa. Yeah, that was good. I heard 6 and 0. I like that. Who's that? Chase? All right. Nice job. 6 or 0? What do you think? Or 1, right? I guess there's a 1 up there. What are you thinking? How many Sixers are there? How many people think it's 6? Come on, go out on a limb. It's not going to break. How many of you think it's 1? How many of you think it's 0? How many honest people do we have in here that you don't know? All right, very good. That's very nice. All right, listen carefully. Anything to the first power is the base number. Anything to the first power. I hate to say anything, but anything to the first power is the base number. Well, them apples. Okay. So don't get confused. Meaning, if they throw something out there like 256 to the first power, what is it? 256, right? Okay. Pretty easy stuff. So far, so good. Next one. What if we have something to the 0 power? All right. So I heard 0 and I heard 2. Yes? Okay. Are those the two answers that you'd like to? Okay. So far, you're all wrong. It's not 0 or 2. It's 1. Anything to the 0 power is 1. Why? Okay. Anything to the 0 power is 1. This is, for some odd reason, this is the harder of the two, because sometimes we'll do this and you'll put 17 or somebody will put 0. Okay. Anything to the 0 power is 1. So far, so good? Yes? All right. I don't think we need to do a ton of examples there, but okay. Couple of order operation problems. Okay. We talked about the exceptions to the rule yesterday, and it sounds like we made a couple boo-boos over homework last night, which is okay. That's where you want to make them, right? You don't want to make them on the quizzes and tests. Okay. So if we have something that looks like this, first question is that an exception to the rule? No, it is not. Why not? Okay, Han. All right, very good. This is where I don't want you to get confused. The exponent is not in the parentheses. Okay, which means we do what first? Yes, we do in the parentheses. Now, we talked yesterday when we solve inside the parentheses, what happens to them? Okay, the parentheses go away, but look what we have to carry down. We have to carry that 2 down. That didn't go away because that's on the outside of it. Okay? And again, we do our normal thing. We rewrite the problem. Bring down everything that we didn't use. Okay? What are we doing next? Emma? The exponent. Very good. We solve that. Everything goes away. Do we do addition first? No. There's an exception to the rule. Okay? We get 34 plus 1 will give us 35. There's 5 steps. Okay? But I wanted to show you this. When you do have a parenthesis, I'm sorry, when you have an exponent on the outside, okay, nothing changes, right? Please excuse my dear Aunt Sally. Parentheses come first. Okay, that exponent gets carried down. Okay, that's a totally different scenario if it was inside. So far, so good. Okay, right, you can do that. That's not difficult. Okay, next one, and then we'll move on. I just want to show you these to make sure. This one's pretty involved. That's pretty involved. Now, this is what we're getting to today. This is just a little preview, I guess. Okay, what are some of your observations here? Right, this is not an order of operations problem. Okay, it is partly distributive, but what else do you see in there? A variable. Is the variable all the same? They're all n's, right? Which your mind then should start thinking, I have to. I got to combine things. Yes, correct. Okay. All right. Michael said it best. I see the distributive property. Before I start combining things, what am I going to do first? I got to distribute first. I have to get rid of the parentheses. Okay, so I have to do this. Right, so this is like a multi-step problem. One, you have to distribute using distributive property, and then you have to combine like terms. So there's 2 concepts going on here, right? So when we multiply 3 times 2n, we get 6n. You agree? Okay, plus 6, right? 3 times 2. All right. Now, this is where it gets interesting. Outside the parentheses here, there's a negative number. Yes? Or a negative sign, I should say, sorry. Is there a number out there? There is. There is. We just in the math world, we don't write this. There is an invisible 1 out there. So there's a negative 1 out there. Okay? Yeah, I know. So we have to do one of those. What's negative 1 times 4n? What's a negative times a positive? Anybody know? That would be a negative 4n. A negative times a positive is a negative. What's a negative times a negative? Negative times a negative is a positive. I'll go over these rules here in a minute. Well, you should have briefly been briefed on this in 6th or 5th grade. Plus 6n, right? There's nothing to do there. Minus 3. Right? There's nothing to distribute on that. Don't worry, we'll get it. We'll get it. All right, so what can we combine? Michael. Whoa, there's no plus 4 in it. I got a positive 6n, a positive 6n. What's that give us? 12n minus 4. That is a positive 8n. That's 12n minus 4n is going to give us 8n. Does that make sense? Right? It's just like what you have to kind of ignore is the n. Right? Just do the math. What's 12 minus 4? 8. Slap on the n. Right? Right, now we have some other numbers. What are those other numbers called? Yes. Nice job, Mike. We have constants. What's 6 plus 1? Those are positive numbers. 7. What's 7 minus 3? That's a positive 4. That is your answer. Does that make sense? There's a lot going on. No question about it. At the moment, not done yet. All right, everybody good? Well, listen, this is what we're getting at today. So no need to panic. We're gonna do these problems together. All right, so let's go over that raised a red flag to me. Let's go over positive and negatives. When you multiply positive and negatives. When you multiply positive and negative numbers. Notice we said multiply. Right, there's 4 of them. So if you multiply a positive number times a positive number, what kind of number do you have to get? You have to get a positive. And I'll give you an example. That's like 3 times 2. You have to get a positive number. Okay, next one. I'm gonna put this in this chart here easily so you can understand that. Negative times a negative. Yeah, okay, that gives us a positive number. Very good, sir. Negative 3 times negative 2 yields us a positive 6. That's correct. How many of you know about positive and negative numbers? I'm curious. Okay, all right, here we go. If you have a positive times a negative, what does that yield us? Emma? A negative. So we have a positive 3 times negative 2. That's going to yield us a negative 6. And the last one, if we have a negative times a positive, what does that give us? Look at step 3. If a positive times a negative gives us a negative, what's a negative times a positive give us? a negative. So if we have negative 3 times a positive 2, that's going to yield us our negative 6. So if you look at the signs in summary, if the signs are the same, what's your answer have to be? Not the same. Positive or negative. If your signs are the same, your answer has to be positive. If your signs are different, it has to be a negative. That's the way it is. All right. So that screen right there, you may need to study that. You may need to look over that. 4 or 5 of you only raise your hand about positive and negative numbers. Now, we will, throughout the year, we will do these problems so you get better at these for sure. No question about it. All right, everybody good there? All right, moving on. Okay, we're going to talk briefly, because we've already talked about this, about identifying terms. Right, this was like the first thing I think I introduced you. Right, so if we have something that looks like this, it might look really complicated to you, but we'll walk through it. 12y squared plus 6y plus 7x plus 2. Okay, I know that probably looks kind of confusing to you. Okay, let's identify a couple things. What are the terms? What are the terms? Anybody know? 12y and 6y? Okay, okay, anybody else? Tyler? Oh, I thought you had your hand up. Anybody else with the terms? Remember, the terms were all the different items up there. Are all of those different? Are all of them different? Okay, is that different than y? Is y squared different than y? Yes, it is. Absolutely. So, let me ask again, are all of those different up there? Yes. That means that they are all terms. Oops, I don't want to do that. You don't put a plus sign in there, we put a comma. These are all the terms, identifying the terms. They're all different. Oops, why do I keep doing it? Okay, that's the term. What are the constants? If there is any. Okay, 2 is the only constant. Good, I think we have that under control. Okay, how about these? The variables. What are the variables? Y squared and x. Y squared is different than y. Absolutely. Y squared is not the same thing as y. Okay? And I mean, I guess sometimes I like to teach this as, pieces of fruit. Right? Y squared is not the same piece of fruit as y, because it has a little 2 up there. That's totally different. That means something. Okay? Now, if we didn't have the little 2 up above y, then what variables would we have? We would just have y and x. That is correct. Very good. And the last one you should know. Yes. Coefficients. What do we got for coefficients? Okay, no. Remember what coefficients are. Michael? Yeah, they're just the numbers. Just the numbers. We've already identified the variables in the variable section. The coefficients are just the numbers in front of a variable. Okay. So far, so good. Yes. All right. Let's try one on your own. What do you think? All right, let's try one. All right, here we go. No. All we're doing is identifying. That's all we're doing is you're naming the terms. That's all you're doing. There's no solving this. Nine R. 8R. 8R squared. Yes. Okay, so we need the terms. We need the constants. We need the variables. And we need coefficients. I'll give you a minute to solve that. All right, we ready? All right, what are the terms? Colin, what are the terms, buddy? Okay, I think I heard 3y. I heard 9r. And I heard 8r squared, yes? Michael? Yeah, they're all terms. They're all terms. The only way that you would not, I'm not going to put one up here, but the only way that you would not have a term if you would have 3y plus 3y plus 5. Is 3y and 3y, is that the same piece of fruit? Yes, it is. So that only counts as one term. Does that make sense? Okay. Maybe I'll put one up after this. What are our constants? Ian. 5 and who? Yes, that is correct. What are our variables? Emma. Y, R, and R squared. That's correct. Very good. Coefficients. Kellen. You gotta pay attention. Cole. 3, 9, and 8. So numbers in front of the variables, Kellen. All right. Pretty good. Right? You can identify the term. Of course you can. You're smart. All right. Here we go. Spell everything. All right. Combining like terms. We'll start off easy. Combining like terms. This is where we struggle. Do? What? Oh, jeez. Oh, my Lord, that's bad. That's bad. That better? Yeah. I told you I could spell everything, but I can't. Right. 5x plus 2 plus 3x is something the same. You have the same piece of the fruit up there. Yes, we do. Okay, on. Okay, so we got to add these together to get 8x. Is 2 a different piece of fruit? Yes, it is. So our answer here, when we combine like terms, is just simply 8x plus 2. That's all you can do. That is the answer. Okay. So far, so good. All right, moving on. Here's the number. Here's the next one. $19 plus 6x plus 2x plus 3x squared. Do we have the same pieces of fruit? We do. What are they? Okay, that is correct. Now, 3x squared is not the same piece of fruit because it has a little 2 up there. It has the exponent. Okay, now listen carefully. So I'm going to tell you how to write these. Mathematically, we go left to right. Listen carefully. The variables that have exponents, I guess let me be a little bit more specific. The variables with the higher exponents always come first. And then variables with no exponents. And then the constants always come at the end. Okay? I wish I could tell you why that is. I don't know, but that's how you write it. So our first one here is 3x squared, right? Okay, because that's our variable with the highest exponent. Plus, what do we put next? Very good. We combine those because they're the same pieces of fruit. Plus 19. That is your answer. That's all you have to do. There's no solving to it. You don't know the value of the variable, so you can't solve. That is solving right there. You combine like terms. Okay. Next. All right, here we go. 13c plus 6u plus 8x plus 19 plus 7. All right, what do we got? Next. You got it, buddy. That's exactly right. The only thing you had to combine here were the constants. So far, so good? Yeah? Okay. Yeah. All right. Now, hang on. Let me help you here. Let me help you real quick. Okay, this is similar to the one that I showed you before we did this, correct? Okay, the one thing that you try to do, what do you see up there that really isn't there? I don't know any other way to say that, sorry. Yes. Here is what I do. You are correct. Good job. Michael. I always do that just so that I don't forget. Okay, I do it now. It's just part of math. Whenever I see a negative next to parentheses, I always put an imaginary one there. Okay, you can't just, how do I say this? You can't multiply a sign by a number. It has to be a number and a number. Does that make sense? Okay, hence the invisible negative one. All right, so here we got to distribute. Right, I do that. And I got to do this. I get plus 3. So far, so good, right? Okay, here we go. What's negative 1 times a positive 7? Just yell it out. Negative 7x. Remember, that simple rule. If they're different operations, it's a negative. If it's the same operation, negative, the answer has to be positive. Right, so what's negative 1 times a positive 2? Whoa, negative 2x. There's no x there. Just negative 2, right? Plus 10y. Can we combine anything? Yes, we're going to combine 9x and negative 7. So what's 9 minus 7? Okay, now this is where you got to be careful. Remember that x is still attached. Remember that. That's part of the piece of fruit. That x. Okay, what else can we do? Okay, well, hang on here. What about this? What about our 10y at the end? Yeah. Now can we do this? All right. Now I will tell you this as well. Remember how we said the variables with the highest exponent come first? Normally when you write these, you write the variables in alphabetical order. That's correct. Okay. So you gotta know your alphabet. I know. Hey, it scares me too. You gotta know it. All right, are we okay with combining like terms? Okay, now we did some, I would say these are medium in difficulty. These are medium difficulty. Yeah, these aren't the hardest of the hardest. Okay, but listen, you understand the concept of how you're adding the same piece of fruit. This is not difficult, right? You just have to be careful if you get a distributive property problem to make sure you distribute right and make sure you get your positive and negative right. That's it, right? All right. We good? Any questions? All right.